Good afternoon, everyone. Hope you're having a joyous weekend. Yeah, no, my ears are too loud. Again. Of course. It feels comfortable before you start speaking, then you start speaking, you're like, nah, I can't do it. Good to have you all here. This is going to be ideally a short and sharp stream. Barney wants me to boost. Barney, are you trolling? Boost the master volume a bit. Yeah, nah, of course. Barney's still speedrunning the Get Banned challenge. This will be a short and sharp stream. I spent some time last night editing the video of last night's stream. So that's on YouTube now. So if you're in Twitch, in chat right now, there should be a link down below somewhere to my YouTube if you want to check out last night's stream. If you're watching on YouTube right now, hello. Lovely to have you here. I was editing that video last night. I also did like a tiny bit of touch up to some of the code, just got rid of some of the debug stuff I'd commented out. Git commit, git push. So that's also on my GitHub now. Again, if you're on either Twitch or YouTube, there should be a link down below somewhere as to where to get that. And as I was touching up that code and editing the video, I was horribly ashamed of some of last night's incidents and issues. So I wanted to take a little bit of time this afternoon to just try and tidy up some of that code so that we're ready to go next time. Once we want to start working further through these challenges, we've got a better, cleaner foundation to work from. So this is kind of part 1.5. I just wanted to do some tidy up, but we'll see how we go. Geckham, can't stay unfortunately, but good luck. Thank you very much. Catch you next time. Alana, Frenchie, Barney, fantastic to have you all here. If you missed last night, what are we doing? We're working through the Cryptopals challenge series, and it's essentially building and then breaking various kind of crypto patterns and primitives. We worked through Babby's first, converting hex to base 64. That didn't give us too much trouble. We worked through the fixed XOR challenge, just XORing two equal length strings against each other. We worked through the single byte XOR cipher challenge, and this is where some of our troubles started to crop up, where essentially we were given this hex encoded string. We had to decode that to bytes, and then brute force through the 256 key range of a single integer what the kind of single byte XOR key was. And so what we did was we iterated through each of those keys, decrypted it, had a look at what we got, and tried to programmatically work out if it looked like English or not. And that's the part that I made some terrible mistakes with. And then challenge 4 was essentially the same thing as challenge 3, except we were given a whole bunch of candidates. One of these, I don't know which one it was, one of these was similar to challenge 3. It was ciphertext under single byte XOR. The rest were noise, essentially. And so we had to kind of reuse that same pattern for 3, you know. For each of these, we did the 256 range brute force, picked the most English looking thing for each of these, and then out of the entire set we got back, picked the most English-like of the most English-like results. And that's where the mistakes we'd made with the previous challenge really showed their head. Our original solution for challenge 3 really should never have worked. It felt like luck that it was, and in 4 it completely fell over. So anyway, that's what we got through last night. That work is on YouTube if you'd like to check it out, or on GitHub if you just want to see the code. And today I wanted to take the time to clean it up. Some more housekeeping as well. When I was editing last night, I was quite shocked at the audio quality. I wasn't happy with the microphone, so I spent some time today, tweaked that. Hopefully there's a bit less clipping and a bit less harshness to the vocals, but we can smooth that out as time goes on. And the jankiness of the VM. There was like this point where the VM just almost completely froze for like a minute. I looked into that error that Linux was throwing, and it pointed to so I'm actually running on a Windows machine on my gaming rig. The issue pointed to Windows having Hyper-V enabled, and when that's the case, VirtualBox enters a kind of an emulation mode to do its hypervisor duties. and it's not performant at all. I could have sworn I'd disabled Hyper-V in the past for this reason, for VM reasons. Turns out I'd turned it back on for WSL and forgot to turn it off before the stream last night. Fingers crossed, the VM jankiness problem is now gone, and I also took the chance to bump its RAM. So hopefully this VM behaves itself better from now on, but all of these are things that we'll just fix as we go, right, if they're problematic. So, as I said, I wanted to, as I was kind of tweaking some stuff for publication last night, I was seeing things in here that I wanted to clean up. So the first thing I don't like, Atwolf says, time to migrate to VMware Workstation, plays a lot happier with Hyper-V. Possibly. A bit of behind the scenes here is that my daily driver workstation is Linux, for which I don't want to use VMware, because installing VMware on Linux, like, it's a binary thing that just like shits all over your disk, and I've never felt good about that. So I rock VirtualBox on my Linux workstation, and I do have some VMs on this machine as well that I'm not using right now, but came from there. I like to be able to copy paste kind of my templates and stuff from my other workstation. So there's method to the madness as to why I use VirtualBox, but there you go. If you're struggling with virtualization on Windows, apparently check out VMware Workstation. Good tip. So this text file here was kind of that big haystack of those potential ciphertexts. And I didn't like it kind of sitting here in the middle of all our solved challenges. So let's shove that in a data directory. Kind of keep it squirreled away. So PyCharm should handle this for us if we refactor move file to the data directory and refactor. Yeah, right, Atwolf doesn't feel good, does it? So we've used PyCharm to move that file around with a right-click refactor. And ideally, it has also gone through and changed all the references to that original file. Like here, we can see here, it's now referencing it from the data directory. And there's another one here. The joys of an IDE, right? Making life easy sometimes. So that's good. I wanted to get that out of the way, so that's nice. This file here, I'm pretty happy with that. I do want to go through and add some better documentation and maybe some more tests for stuff in the util library, but otherwise, let's actually get rid of that line there. Let's just clean it up a bit. Otherwise, I'm pretty happy with that. Fixed XOR. arg1, arg2, res is that, print res.hex. I'm pretty happy with that. Challenge 3. This file here is implementing the attack against that one hex string that we know is single byte XOR ciphertext. Let's just wrap this text here. Make that look a bit cleaner. I'm pretty happy with all that. Yep, I'm happy with that. Challenge 4. I'm happy with that. That looks fine. Do our imports look healthy? A bit of a mess. What about these imports here? That's fine. That's fine. That's fine. So yep, that looks good. This looks good. That's not too bad. I'm going to delete this debug code here. We're going to play around with that shortly. This here is something I thought I wanted to tidy up. We'll get to that shortly. Def main, open that. Candidates equals bytes from hex. That. I don't think we need f.read lines here. I don't think we need f.read lines. I think we can just do for x in f. Because I think when you iterate over an open file, it spins off lines by default. And when you do that, do you avoid the stupid new lines so we don't need to strip anymore? Let's just play with this. Python 3 with open, let's see, password, read as f, print x for x in f. So like it is giving us each item, but it does have this little new line at the end of each thing. That's fine. This, I think this here is still cleaner than what we're currently doing, which is this. f.readlines. Yeah. You get the same result. There's an unnecessary call to read lines here, which is like realizing a list in memory, which we don't need to be doing. So we can... yeah, sorry. So this is some of the tidy up I did last night. I did that tidy up here. We're doing bytes from hex, line.strip for line in open. So here we can do for line in F. We don't need the read lines. We've got to fix this X. At wolf, isn't it just read line that strips the N? Perhaps. All right, Linux is still unhappy about it. So we're already getting complaints on our wall. Fantastic. So at wolf, I think you're saying F equals open etc password read F dot. So we get F dot read line. Okay, so you F dot read line, you can kind of keep calling that. It keeps spinning off lines. Looks to me like they've still got the new line at the end. Help F dot read line. What does the documentation say? Read until new line or end of file. I think you just have to deal with the fact that you get all these new lines when you read lines from a file. Probably makes sense for some reason. That's looking a little bit healthier. And then we print that over that. I'm happy with that. So here we're just doing like pre-processing to kind of like byteify each line and call them candidates. As I said, I think we can do better than this. Like, I realized last night we were scoring candidates, right? Using this function that I really want to be digging into today. We were building results into a dictionary, right? To then simply do dot items on the dictionary, sort them, and get the winner from the end. I think this can be simplified. I think we can do return sorted. So we want to sort the candidates, and the key we can set to be score English text by frequency. And telling Python, use this function to sort this sortable list. Like, what does sorted take? We're going to take like an iterable or something generic. Got to point to my virtual environment. Oh yeah, right here, the big yellow banner, that would help. Let it do its indexing. So what does sorted take? Sorted takes an iterable and an optional key function. And the key function has to support less than. I think as long as like the function's returning something where it's like, as long as the function returns something so that Python can say, okay, sort the numbers biggest to smallest, smallest to biggest, as long as like A and B, you can put a less than between them. For A and B having been returned by this function, I'm pretty sure it's a legal key function. So I think we're going to do sorted. We want to sort the candidates with the key being scoring English text by frequency and get the last one. I think that's all we had to do. So let's comment that. Comment this, we don't need it anymore. Run the main function. Seems to have worked to me. Nick1234 Ash donated $100 million. That's very generous of you, but I also know it's not true. Good to have you here. Hello. So I think this here, I mean, it's a little bit golfy, a little bit hard to read, but it's like so much more efficient than building an unnecessary dictionary to then just call items on it and do the sorting anyway. So I think that's a bit cleaner. So this function here now just breaks the single XOR cipher for each item in the haystack and then returns the most English looking one of those candidates. Let's add some quick documentation to this function. Given a haystack of potentially single byte XOR encrypted ciphertexts, brute force each and return the plain text of the ciphertext that most resembles English text after being brute forced. And the reason I like add this documentation here is because then when you like in an IDE, you hover over this function, you get that pop-up telling you what you just wrote. So it's kind of helpful if we want to use this later, we can hover over it and be like, oh yeah, that's what it does. Given a haystack of potentially single byte XOR encrypted ciphertext, brute force each, and return the plain text of the most English-looking one. Bit wordy, but it's a bit of a nutty function. I want to move this now to the utilities. Something we didn't do last night, but this function could be useful in future. So I'll move that to utilities. And this is now looking pretty clean to me. I'm happy with that. Save that, close it. Now the nightmare, this util. This file here is getting out of hand. And this score English text by frequency, like there was that horrible bug last night where I thought these were fractions. Turns out they're integers. More integers greater than 1. They're not fractions less than 1. I want to fix this function. I want to play with this function more. But let's start at the top. Let's write some documentation for some of the stuff we wrote last night. This function here simply decodes hex to bytes and returns the base 64 encoded, and returns a base 64 encoded, returns a base 64 representation of those bytes. Cool. Documented. Fixed XOR. Oh, one more thing I fixed up after the stream last night. I had this assert in earlier in the code to ensure that both arguments were of the same length. I managed to delete that during some work and some refactoring. So that's been added back in. That got lost halfway through the stream last night. This function, return take 2 bytes arguments of equal length, return the XOR of those, or return their XOR. Cool. That test was given to us by the series. God, words. This test case was given to us by the challenge itself, so that's good. This test case here was also given to us by the challenge. It looks like these both faithfully exercise the functions, so I'm happy with those. Single byte XOR. Turns out we wrote documentation for this. Return a variable length plain text XORed with a given integer key. That sounds fine to me. These test cases, I was looking at them last night going, they don't do a great job of, I don't know. I just thought I wanted to add one more. So if we just add another test case, which is single byte XOR of A, B, C over hex 41, we should get 1 and 2 back. Does that sound right? Probably should have thought about that before I opened my mouth. Let's run our tests. Nah. Expected 012, got 032. Is that true? I'm pretty sure it is. So ord of B, hex of it is 42. OX42 XOR OX41 is indeed 3. Yep, fair. And then same again for C, which is going to be OX43, right? Yep. OX43 XORed with OX41 is 2. Cool. Run the tests. Good. We were just like, the previous tests were like all regarding A's and 41s. I just wanted to add a bit of flavor in there. I feel like that exercises the functionality a little bit better. Not that it's a very complex function anyway. But I'm happy with that now. Now here's, okay. So recall, a big challenge I had last night was, it must have been like 3 or 4 times that I used this table as though these were fractions. That is to say, this, which is meant to represent that E appears 12% of the time in natural English text, I was picturing in my mind that this was actually 0.12, and I was multiplying it as though it was a fraction and using it as though it was a fraction. I didn't do it just once, I did it like 4 times. I feel like I kept making that mistake. I just stole this from cornell.edu, so that was their decision to represent it like that. But the fact that I kept getting confused tells me that we should actually change this now to be what I thought it was going to be. Because otherwise, I will just keep making the same mistake. And the fact that I kept using it as though it's in one shape means that that shape is probably the naturally like best fit shape for the data. So, what is the easiest way for us to do that? We just yoink it and chuck it over here in a REPL, and we'll just go like A equals that. It's not what I wanted. E in character frequencies equals that. Good. So now I want KV for KV in char frequencies to items. Good. But now what I can do is I can multiply this by 0.1. By 0.01? 0.01, that's what I want, right? Or I can divide by 100, same thing. So I can kind of rebuild that dictionary as though it's in the shape I was picturing it was all along. Some of these numbers seem like they're getting a little bit crazy. Can we round those? Let's round to like 4 decimal places. Cool. So let's say D equals that for a new dictionary being that. Now what is the sum of D's values? Like pretty close to 1. I don't know if that is not 1 because the original data didn't quite add up to 100, or if that's like an internal floating point error for Python. Like this is starting to look more like it's a bad, I don't want to say bad data, but we did just like do a round operation, like we've just done some damage. What if we do this? Delete the Z from that dictionary. Yeah, it's gone. And we sum them. Now we go 1 minus the sum. Oh, it's a really ugly number. Yeah, what if we do dz equals that? I mean, Z's now like looking really rank, but what is the sum of our values? Now it's 1. This data feels like it's just, we've damaged it a bit by changing Z from what was Z 0.07. No, it was here 0.0007. We've changed it to 0.0007 and then garbage. But it's pretty much a rounding error at that point, but I did really want this to add up to 1 in case it's important for some of like the chi-squared math or something. And we also changed the shape by dividing everything by 100, so everything's really a fraction now. I feel a lot better about this than what we had previously, so I'm just going to yoink that. Hope that I haven't done too much damage in the process. I guess we'll find out sooner rather than later. Now, if we refactor, no, code, reformat code, There we go. That's looking much nicer. Did we break our tests by doing that? If we run all of our tests again... Yep. Something broke. Something broke bad. I kind of want to just like play with this and probably like rewrite it anyway. That was kind of the plan for the bulk of today's stream. Break single XOR cipher. Use character frequency analysis to brute force single byte XOR cipher text. Documentation looks good. Doc test looks good. Again, we've got this like redundant building a dictionary then sorting it stuff. So can we just... Oh, here we go. We can probably just yoink some of this. So we build the candidates, which is the same as this here. We can probably just do that. So when it comes to breaking single XOR ciphertext for English, take ciphertext, and candidates is an empty list, and then we iterate over all the keys. This VM is still a pain in the butt with the mouse. We append to candidates an attempted decryption with that key we're brute forcing. And then we sort the candidates with the sorting function being the scoring function and return the last one. Seems like it's functionally equivalent to what we just replaced, and much cleaner code. I'm happier with that. This is the stuff that we just edited from the S1C4 file, so I'm happy with that. It's this mess here that I want to play with and fix and tidy up. And how I thought we could do this was, what if we grabbed some English text from somewhere like Wikipedia, saved it to a text file, and just played with this function, ran this function across like every line from it or something like that to just kind of get a feel for what's going on. Like we were doing that last night. We were getting a feel for how this function works against the challenge data. But then once we kind of got to the end of the night, we fixed some really dumb bugs. We never went back and re-examined what that output looked like to see if it looks sensible. So I just think playing with this is probably worthwhile. To do so, I'm going to create a new file. We can delete it at the end of today. Oh, maybe we'll keep it. I've got a habit of calling things play. Like when I'm just experimenting or whatever, it's not, you know, code that produces useful output. It's just me fucking around and finding out. I call it play. So let's play en char frequencies. User bin env python 3 from utilities import that scoring function. Do our boilerplate. Def main is empty for now. If dunder name is dunder main, run that function. Cool. Let's collect some text. Where would be the best place to get some just good general English literature text from? Like, I'm thinking either grab a couple of passages from like Alice in Wonderland off Project Gutenberg, or like some stuff off Wikipedia. I think, because like Wikipedia's gonna have like a lot of punctuation and like weird stuff going on, and it's gonna say citation needed a lot. I reckon if we go Gutenberg, Alice in Wonderland. Twitter while it lasts. No, Frenchie, I said English. I want sensible text, please. At Wolf Lorem Ipsum, it's not a bad idea. I think it's going to kind of like be a little bit skewed. I like the idea of using Alice in Wonderland. Plain text. Like, what if we just grabbed a couple of these paragraphs? I'll admit I've never actually read this, but do we just go from chapter 1, grab this here? It will keep... Yeah, Wolf, I'm thinking... Are you saying Lorem Ipsum will do that, or are you saying Alice in Wonderland will keep the spaces and the word length consistent. I think this is our best bet here for natural English looking language. But I'm curious what you've got in mind. All right, let's have a look. Where's the button to give me some lorem ipsum? I think so, Wolf. I think Alice in Wonderland does feel more fun, right? Here we go. Keeping in mind, lorem ipsum is written in Latin. I know English and Latin are similar, but my guess is the frequency table we're looking at uses like English, like modern English. Probably the safest way to go. What's Frenchy got for us? Natural language corpus data. I mean, that sounds probably like the best thing to use. Also sounds significantly less fun than Alice in Wonderland. But what have we got here? Okay, so that's just frequency of words, not quite what we need. We need literature. What else do we have? Okay, we've got Shakespeare. No, that wouldn't be too bad to use. I mean, we do get a lot of repetition of these names here unnaturally, in a sense. You know what? I'm calling it. I think Alice in Wonderland is the most fun of the lot. So I'm just going to grab this. How much do I want? Let's grab a bit more than I think we're going to need. Yoink that. And let's chuck it in data. Alice.text. Are the line breaks going to be a problem? Possibly, but we can strip them out or replace them with space in code. Yeah, so we've got alice.text. Where's my play file? Here it is. So let's create a function Alice frequencies and call it from main. And inside here, we're going to do with open. Will says use the text from the GPL3 license or the Microsoft Twitter terms and conditions. Yep, nah, I'm calling it. Alice, we're using Alice. It's the most fun. So we'll grab our Alice file. Alice text equals f.read dot replace new lines with spaces and print Alice text. If we run this, yeah, this is looking pretty good to me. That seems pretty short. That seems really short. Ends with, which is very likely true. This text here looks so much longer. When you put it side by side, it looks a whole lot less long. I'm grabbing more text. Oh, come on. Let's grab this. Okay. That's got to be enough, right? Okay, so we've got Alice text. Now let's chunk it. Alice chunks equals. Let's grab what? How long's a tweet these days? It's probably the most relevant chunking size for text. Is it what, like 240 or something? Someone let me know how long a tweet is. So we're going to chunk it. We're going to go Alice text from I through to I plus chunk size, with chunk size being 240. For I in range 0 through to length of Alice text chunk size. I'm just going to grab pprint because I love it, even though it screwed us last night. Let's pprint the chunks. Run this. Like, what's going on there? That looks like a super... pprint is like splitting stuff over lines. So that was a bad idea. Instead, we'll print uline.join over the chunks. Cool. So this here is just us. Why does that start off with a lowercase word? Great, I messed up my copy paste. There we go, we missed a line. Cool, cool, cool. We don't need to print Alice text anymore. Run this. Cool, so these lines go to the right. They're all the same length. Some of them end with a space, but can't be helped. However, the last line is almost certainly going to come up short when you chunk it. If the text was not a multiple of our chunk size, it comes up short. So how about we just Alice chunks? Let's just get rid of the last one. So if we just slice it through to everything but the last one and rerun it, there we go. We've got, how many do we have? Print. What is wrong with me? Print the length of the Alice chunks. I really should learn the hotkey for run. Okay, we've got 35 chunks of text. So now, if we were to run our score English text by frequency across all of them, we should get pretty consistent results, and they should be nice numbers. Like, I was shocked last night with how low, because keep in mind as well, I don't know if it'll stay this way, but our scoring function, I'm pretty sure higher score means more English-like input. I mean, we'll have to make sure that's true. But like, the way we score is basically by punishing text for how non-English-like it looks like. And over time, these numbers were getting like really, really small, like really big negative numbers, which was just odd. So I just want to get them looking like not as crazy and also consistent. Like we need this to show consistent results. That's enough to do about that. Let's run it. No, I actually have to do the scoring before I run it. So let's scores. Let's do the crazy stuff we were doing last night and build that dictionary so we can look into it. Scores equals key score English text by frequency of the key for k in Alice chunks. And then we p-print the scores. They're not going to be sorted. Let's just p-print them. We've got a complaint here because scoring English text by frequency, I set it to take bytes. Even after I complained that like, oh, base64 returns bytes and that's kind of stupid, I made all my stuff take bytes just in case it ever needs to work with semi-binary data. So let's just encode it to UTF-8 or whatever the default encode is these days. Pretty sure it's UTF-8. And run that. Alright, what's pprint doing here? Oh no, we're good. Yeah, see, these numbers are jumping all over the place, which is really odd for chunks of text from the same body of work, right? So that tells me we've got grave problems with our scoring English text by frequency function. So I'm going to take a very quick 5-minute breather, and we'll dig into the score English text by frequency function and fix it. Like, by me doing this earlier in the stream, I think I broke it more than it's already broken. This was important. We now need to kind of compensate for that, but I think we've probably got some work to do. So after a very short break, we'll be diving into that. For the meantime, grab a glass of water, stretch your legs, and I'll see you in a moment. And we're back. Legs are stretched. I didn't fill my own water bottle. That was like the one thing I wanted to do and got distracted by my phone. I'll be back with a full water bottle in just a minute. Alright, water acquired. Let's see what we can do about this absolute travesty of a function. We'll keep punishing our non-printable characters by 50. Perhaps after we're done with this we can decide if that's still worthwhile and if it's a good amount to be doing it by. So this is fine. I'm just pre-calculating the length of text so I don't need to keep doing it in a loop. Not that I know if that makes a performance difference, but it feels like it's being kind to the computer. Getting the list of our printable characters as integers seems reasonable. We'll revisit this soon. We set up our initial score, that's fine. So an empty string will have a score of 0. It's like, well, I don't know what to do with this. Ooh, I wonder if that's dangerous. Because almost any text, unless it perfectly conforms to this, is going to have a negative score. If it perfectly conforms to this, it's going to have a score of 0. That's almost guaranteed to not happen. In which case, when we start punishing it for not looking enough like English, score will reduce below 0, and thus an empty input will have a better score than virtually any input. That feels problematic. Let's just make a note of that. I don't know. Let's address it now. Let's just assert that length of text is greater than 10. For now, text is not long enough to give a meaningful score. That way, if we ever do call this function over something that is too short to be worth scoring or to be reasonably be scored, we'll at least get a crash rather than bad data. Like, that's why I like to sprinkle these asserts throughout the place. It's in case you start kind of holding a function wrong, you get yelled at rather than have it give potentially misleading output. So we'll just for now assert that the length of text is at least 10. So we set up our score to be 0. For each byte in the text, if it's not in printables, we reduce score by our punishment value, which is 50. Abel said, should the non-printable be punished in more of an exponential nature? The more non-printable, the higher the punishment value for each one. Possibly. Possibly should, yeah. Like, maybe you can get away, like text could be able to get away with a few unprintable characters, but once you start to have more than what seems reasonable, like the score gets worse, like punishment gets more and more, perhaps. I mean, yeah, not a bad idea. I think we can perhaps leave it like this for now. Let's make a note of that. Should text be punished exponentially more given higher incidence of non-printable chars? Thanks, @Wolf. Good idea. Something to keep to consider. Okay, so this is where we get to like all of our like chi squared stuff from last night, which just for a quick refresher, like Like we eventually ended up using chi squared after a false start of a different, more, I guess, like naive algorithm. But that naive algorithm was completely never going to work anyway because of other errors we had to do with the frequency table being whole numbers or numbers greater than 1, and probably other bugs. I probably had like a shit ton of problems with it. Anyway, we now use what's called the chi-squared test, which smart people on the crypto Stack Overflow or Stack Exchange seem to suggest for this type of job. In particular, I found this description here to do with an example chi-squared test for categorical data, to do with like a population, a sampled population of whether someone's a white collar, blue collar, or no collar worker. I found this passage here to give me the best appreciation for what chi-squared should look like in practical, like simple practical use, as opposed to this here, which did not help me whatsoever. So if you didn't catch last night, then this this passage is what really unlocked me. It boils down to calculate, using the expected kind of frequency graph, how many occurrences of a given character. Like let's say the character E. Given that E's apparently crop up about 12% of the time in natural English text, so first of all, okay, observed. Count how many E's are in your text. Easy. Expected. Multiply the length of your text by 12% to find out how many E's you expected to get. Subtract that from the observed, square it, divided by the amount of E's you expected to see. It gives you a number. And what do we decide? Chi-squared. If you're like on the money and the observed equals the expected, this numerator here, when you square it, 0 squared is 0. 0 divided by anything is 0. You get 0 at the back end of it. If things are like way off, if you observed 100 and expected 0, then the numerator here is going to be 100 squared divided by 0. Things break. Okay, so chi-squared is going to break if expected is ever 0. So let's go 101 to 1. So let's say we observed 101 instances of E, and we expected 1. The numerator becomes 100 squared divided by 1, which is a big number. So the chi-squared number gets bigger the less fitting things seem to be, which is an important note. I'll just note this down for now. Chi-squared. The chi-squared number is 0 for bang on, else it gets bigger the worse things seem to be. Chi-squared blows up when expected equals 0. Expected count equals 0. So we were doing chi-squared. Okay, so the expected count. So for each character in our frequency table, for the character and its expected frequency, which is now a fraction. So here we're doing, we're just getting the uppercase and lowercase of C, and then getting the integer representation of it. Cool. Expected count was the expected frequency times the length of the text. That seems fine to me. The observed count is we count uppercase and lowercase instances of the character in text, add them together. That makes sense. Then we subtract from the score. The observed count minus the expected count squared divided by the expected count. This seems to be a correct chi-squared to me. What I was going to do, I was thinking we should lift this out into a function. So let's define chi-squared and give it observed count, which is a integer. This gets a bit tricky. I think observed count's going to be an integer, but the expected count is going to be a float because it could be fractional. I'm a little bit new to Python type hints. If we give an observed count of float just to keep them both the same type. And it returns float. Return 1.0 for now. If we call cheese squared with an integer instead of a float, do we get yelled at? Cheese squared 1.0. Like, does the type float allow you to give an integer? We're not getting yelled at. YOLO. Let's say we accept floats, but it seems like accepting ints is also legal. So now we want to cheese squared. We want to return. What is it? It's the observed count minus the expected count squared divided by the expected count, right? Observed minus expected squared over expected. And these are counts. Yeah. Observed minus expected squared over expected. Observed minus expected. Seems good. Bit of documentation. Return the cheese squared. What's the output of a cheese? Like, what do they call it? A cheese squared test. We call it a cheese squared test result. Sure. Return the cheese squared test result for a given observed and expected count. Let's just add that Wikipedia in there. Do we get given any good test cases for cheese squared? Like, I know that they're giving it an approximate here. $90 and 80.54. Cheese squared over 90 and 80.54. It's not going to give us 1.0, but I'm just going to do that so I can run the test. Yeah, so get back 1.11, which lines up with this. So if we subtract from that cheese squared 1.11, which is what it is approximately, get the absolute value of it, we're going to say that that is less than 0.01 to kind of show the whole approximately equal thing that Wikipedia is telling us it should be. So that test should give us true. Yeah, so we've got a test failing, but it's not this test. So this test case was taken from Wikipedia. It tells us that this is not completely stupid. Okay, so we've got our cheese squared. So here, we want to subtract from the score the cheese squared of the observed count and the expected count. So we haven't actually changed any logic there, I don't think. Oh, we should add some commentary here. If observed and expected are equal, the chi squared test result is 0. Else it increases as the delta between the counts increase. Just so we've got a bit of a reminder of what a chi squared is. i.e. bigger number equals worse match. I'm sure this, if a statistician ever was to see this, they would yell, I'm sure. Chi squared is telling me I'm pronouncing, am I pronouncing chi squared wrong? Frenchie, is that what you're saying? Gives the statistician something else to yell about. Great. Yep. God, I'm ignorant and stupid, aren't I? Thank you, Frenchie. Frenchie, are you a secret statistician, mathematician, math buff who have been irritating every time I've said chi. I tell you what, I'm going to continue to call it chi out of habit. Chi-squared. Chi-squared. Pro tip, you resemble those accusations. It's pronounced chi-squared. Alrighty. Chi-squared. My bad, y'all. I don't think we've actually changed anything. We've tidied things up by lifting this into a function. I don't think we changed this at all. Oh yeah, we want to consider rewarding spaces. I forgot about that from last night. Dang it. How's Alice looking? So like Alice is absolutely all over the shop. So what am I doing wrong? Am I just completely misusing chi-squared as like a scoring method? Time for some awful debugging. What am I going to do? So I'll print the text. And then while we're running through each of these frequency items, punishment is the chi-squared, and then we're subtracting the punishment from the score. Punishments is an empty dictionary for each of these punishments. The punishment for the character equals the punishment. Punishments for the character is the punishment. And at the very end here, I will print key value for KV in the punishments items we want to sort this with the key being the values. So now for each line that gets fed to, or each chunk of text that gets fed to this scoring function, print the line, calculate the punishments, and then print the punishments in order. So we can see which of the characters each line messed up on the worst. And what the value of that punishment is, according to chi-squared. And we get a crash. What are we doing wrong? That's right. I've completely messed up this way to sort a dictionary. What we're going to do is we want to sort the items and give that the key. And this squiggly is in the wrong spot. Is that right? No, we get awful red at the end here. So sorted dictionary print. That seems like it makes sense. Let's run this. Okay. Yep, so for this line, Alice was beginning to get very tired. V heard it, K heard it, N heard it. Okay, these are in ascending order, so the really brutal stuff's at the end. I'm going to go sorted. Key equals that. Reverse equals true. Run it again. Okay, so L really hurt this line. M heard it, A heard it, F heard it. These numbers are still pretty small. 76222211. Aren't our punishments like negative 1,000 or something crazy? Oh, some of them are pretty small. Let's also print the score as we're running through this loop. Negative 182. Is this non-printable character punishment hurting this line somehow? Or this chunk? Because these here, I don't feel like they add up to negative 182. Like, what am I doing? What am I getting wrong? What if we print the sum of the punishment's values? This is starting to become a bit crazy. Wolf, are you considering space a printable? I don't know, dude. If it's in string.printable, yes. But this is looking kind of crazy, isn't it? Import string.printable. There's a space there. So yes, space in string.printable is true. For giggles, let's just set the non-printable character punishment to 0. I want to run this again. See, now these numbers start to look a lot closer together, Is our non-printable character punisher going nuts somehow? For B in text, if B is not in printables, I'm going to put a breakpoint here and hit debug. B is 226 and it's not in printables. What is character 226? For B in text, what is text? I mean, do I have Unicode in this Alice in Wonderland text somehow? I do. Okay, I think we've got smart quotes in here. So maybe there's nothing wrong with this. Maybe there was nothing wrong at all today. It's just that Alice in Wonderland has smart quotes in it. Which, because I thought I was being a genius in letting this take bytes, or having this take bytes, and I was YOLOing it in code here, we end up with non-printables. Unreal. Go. You know what? Let's go back here. Let's go to Gutenberg. Let's click back. I clicked on the plain text UTF-8 file. I should have known that there'd be Unicode characters in it. Shouldn't I? Goodness gracious. Alright. Copy that. Search for smart quote, change it to straight quote globally. And the same for the closing smart quote. Oh goodness. Okay, let's stop this and re-debug it and see if this breakpoint still gets hit, if there's any other Unicode in there. Yes. 226. I thought I just got rid of the 226. Like, did I not? Okay, we've got a smart apostrophe. Alice to herself. Here's a smart apostrophe. You know what, Wolf? If we'd used Lorem Ipsum, we wouldn't have had this problem, would we? And I'm sure there's a better way to clean Unicode from a text file, but anyway. Hit the debug button. .226, did I not just... Oh, of course, they're all going to be the same, like, bad character, because it'll be like the Unicode prefixy type byte. For you see Alice. What does for you see Alice have to say? Okay, we've got an M dash. Beautiful. Thank you. I hate it. There's got to be a better way of doing this. Come on. How many more Unicode characters can there be? Poison. Marked poison. Okay, we've got another little smart apostrophe or smart single quote here. Joy. Not how I wanted to be spending my afternoon, but anyway. Okay, now it's running clean. We've no longer got punishments going on. Thank you. The score, we've bumped it back up to 50. And all our scores are looking like more reasonable. Good. Okay. This is just looking very sensible. I'm happy with this. Cool. Let's go back to the play. So Alice, we're happy with. I want to know... I had another thought last night or this morning. I want to know if the score of hello is the same as the score of hello hello. It really should be, right? Like, no matter how much you repeat yourself, the score should pretty much be the same. Let's run repetition. Run this. Don't debug it. Don't debug it. This is why you put those assertions in, to make sure you don't do silly things. Yep, no, I'm happy about that. Let's go s equals hello. Let's check the, oh, that's right, it's got to be bytes, doesn't it? Okay, so we should be able to do s times 5, 6, 7, 8. We should be able to do 10, 20, and 100. Like, I'm expecting these should all come out to roughly, or maybe even exactly the same number, right? Ah, we've got a bunch of debug code. I'm happy to debug equals false. Let's hide all this debugging stuff behind a debug flag. We might need it again. We can always rip this out shortly if we need to. So we'll just print this if debug. We'll keep on building up this punishments dictionary. We can rip all this out later. Here's some printing. If debug, do the printing. Cool. Looks like all the prints are now wrapped in debug flags. Cool. Interesting. Okay. Interesting. Scores get worse the longer text is, which kind of makes sense, right? Because this table, like it does expect Zs every now and then. It expects a G every now and then. It expects an X every now and then. Hello has none of those. And the longer the text becomes, the more it gets punished for having 0 of those characters. Right, okay, actually, if you think about it, hello repeated 100 times is not really traditional English text, right? Like, it's not very meaningful, is what I'm saying. Okay, I suppose it could be up to the caller of this function. If they're giving like a bunch of like varying length inputs, the caller could decide to, if it wants to, kind of normalize the values it gets back, you know, divided by the length of each input. So I don't think we need to actually make any changes. I don't think this function should do the normalization like the caller can if it wants to. So I'm happy with that. I was just curious, yeah, what does like repetition look like? But it kind of makes sense that it gets hurt for not having any Zs in it the longer it gets. Barney, am I still on to the premises for NBN? Yep. Hopefully you're not saying that because the stream quality is no good, are you? Because yes. Indeed I am. Okay. So Alice is happy, and the problem all along was just those Unicode characters. Still bitter about that. How are our tests going? Like, everything's breaking now. Everything's breaking now. So we tried to make this make a bit more sense. We reshaped this because we felt like that would make more sense. And it's broken everything. I think we need to go back to printing out all of these to see just how close the race was between cooking MCs like a pound of bacon, which the result should be, and this nonsense. How on earth did this win? It's got that many unprintable characters in it. It should be like virtually disqualified. Right? Let's just... Okay, so this challenge is broken. Yeah, that's incorrect. So if we just set a breakpoint here, probably the simplest way to see what's going on. No, it's not, because we're not building up that dictionary anymore. Okay. we bring back the stupid dictionary. Barney, if you want to go on my wholesale account, I can get you put onto 10 gig for free. Interesting. I mean, I think I'm pretty good, dude, with what I've got, but if that changes, I'll certainly let you know. Sounds like a good deal to me. Scored candidates equals KV for KV in, no, for, so K, score English text, K, for K in candidates. Okay, so we've built up our scored candidates list. And now we want to sort it. Scored candidates equals sorted KV for KV in the items. We want to sort that with the key being lambda x x1. Now if we hit debug again, there we go. No, we don't want candidates, we want scored candidates. Yeah. Like, what's going, hang on. It's telling me scored candidates is a list, is it? No, I don't want to, hang on, I don't want to sort the dictionary, we've got the sorted on the inside. Gosh, what am I thinking? Debug. There we go. No, I appreciate this might be a little bit hard to see, I'm very sorry. How have we got like some positive numbers in here? How have we got positive numbers in here? Because scoring English text by frequency can't return a positive number, can it? What have we done? Why have I got... Oh, okay. No. At some point I set this punishment to 0. And then I wanted to set it back to 50, but instead I changed the initial score to be 50. Goodness gracious me. That should be 50. This should be 0. What is wrong with me? Okay. Deep breaths. Let's run this again. Cooking MCs like a pound of bacon, as we expect to see. Good. Let's debug it. Look at these scored candidates. Yeah, so cooking. That's hilarious. I thought this was the end of the list, but it's not. But it's like cooking MCs like a pound of bacon, but like the XORing has kind of gone a bit screwy and changed all the spaces to nulls and reversed the case of everything. That's hilarious. So cooking MCs like a pound of bacon got negative 33, and the next best thing, which looks like rubbish, but does have like a bunch of E's and stuff in it, got negative 52. This is looking reasonable. Do all of our tests pass now? No. What's broken? The last challenge. Good. Great. So this definitely passes, right? This third challenge passes. Cooking MCs like a pound of bacon. Good. Now we've just broken the last one. So what have we done wrong here? mean, it looks fine to me. Just our scoring, I think, has broken it. Let's... I think I've turned off all my breakpoints now, haven't I? Bookmarks. How do I get to my breakpoints? Okay, good. They normally show up here. Yeah, we've turned off all our breakpoints. That's good. Challenge 4 is broken. Challenge 4 is completely hanging. Okay. At what layer is the problem? If we just p-print the candidates... No, I'm sick of p-print. It keeps wrapping stuff stupidly. Can I do binary new? No, I don't think I can. For C in candidates, print C. Okay, so if we rerun this, is jumping in this list? I'm pretty sure it's meant to say jumping, isn't it? Yeah, it's meant to say jumping. Good, great, thanks. If bytes jumping is in C, print it. Okay, so... God, okay, no, of course, okay. Deep breaths. Jumping is never going to be in candidates because candidates is literally just a challenge input. It's not the place I should have been doing that test. I should have been jumping into here. Candidates equals break the XOR cipher, good. So now, for C in candidates, if jumping in C, print C. Rerun. Okay. Deep breaths. Break single XOR cipher for the needle in the haystack is not even picking the right needle. Not even picking the most English-like thing, or it probably is picking what it thinks is the most English-like thing, but it's not the jumping trick. So I think we need to go to here now. We've got some debug code here that we've left in, which is very generous of previous us. So breaking single XOR cipher. We get these. Now, this is awful. If any jumping in K for K in scored candidates dot keys. I didn't need to do it like that at all. I didn't need to go through the keys. I could have just gone through candidates. But anyway, if anything in these scored, if the jumping text is in the scored candidates, raise exception, and that's going to make the debugger kick in. Debug. Good. There's our exception. Scored candidates. And they're sorted, which is good. Right down the bottom, where does jumping show up? It's like 3 from the bottom, 2 from the bottom. Apparently this text here and that text there look more English-like than now that the party is jumping. Why is that? I'd like to just grab these 3 if I can. Can I copy values? Can I go to my play file? Look at that! Beautiful. Actually, let's leave those. Let's leave those numbers. Okay. Deep breaths. Jumping. Let's create a jumping function in our play file. And let's kind of debug the score function over these 3 inputs and try and work out why our scoring function is preferring these inputs to this one. I think that sounds like a plan. What time is it? 4:30. We've been going for an hour and a half now. Not too bad. Wasn't planning on making such a long deal out of this, but I think it's worthwhile. I'm going to take another quick breather. Go grab yourself a glass of water, get a paddle pop, cup of tea, whatever you fancy, and I'll see you on the other side. Alrighty, we're back. Just looking at these, there are no unprintable characters in the second best candidate. And there's one unprintable in this one. Then again, Hex OB, that might be like tab or something, right? Chair of OXB. Thanks. What is OB? Vertical tab. That might be considered printable, actually. Yeah, Hex OB is in string.printable. So interestingly, neither of these are triggering the punishment for non-printable characters, which is very fortunate because their scores haven't been decremented by 50. If there was like non-printable in here and this was still greater than -50, I'd be very upset because we've got more horrible issues than I could have imagined. Okay. So in this instance, our punishment for non-printables isn't and can't save us. Why do these strings apparently score better than this one? It's probably not helping this one that's only one E in it. But then again, there's 0 E's in here. There are 2 in here. 3, 4, 5. Yeah. And again, 5 is probably just as bad as 1, right? 12% of them should be E. No, 5 is probably pretty good. Anyway, let's dig into jumping. Candidates equals. Let's pinch these. That's what I want. Right. For candidate in candidates, we want to score English text over candidate and debug equals true. Good thing we left all those print statements in, hidden behind the debug flag, right? Let's run this. So we don't want repetition anymore, we just want jumping. Let's run this. So what should be the winner is getting hurt a lot for no... Oh, it's got a J, and that's really hurting it. The fact that it has a J is giving it a chi-squared for that character of 31, which is massive. The second best got hurt for D, because it's got 1, 2, 3. Yeah, so it's getting hurt for D. A good string, it's got a beautiful score. Like, it's getting hurt pretty consistently across the board for a bunch of stuff, but not very much. Yeah, this is not scoring well because of the J. Like, Now that the party is umping, probably scores better. Minus 45 compared to minus 13. Yeah, you just get rid of the J and it shines and it beats the other ones. So the J is actually doing it harm. So how do we fix this mongrel of a function to not hurt it so much for having a J? Because the frequency table, I was kind of shocked when I saw this last night. Being a Justin, I was very hurt to see that J is actually the second. Is it the second rarest letter, or is this frequency table broken? I mean, it's at the end of the list. Did I get a... I swear to God, if I got a bad frequency table... Based on a... This is... Is J really 0.1% as character frequency for Wikipedia? What do we get? Yeah, J is pretty damn rare. But it is more popular than Q, for example. Whereas here it's showing as just barely less popular than Q, so it's not too far off. What if we found a better table? Frenchie's got to drop to dinner. Yeah. Stupid frequency character. Bullshit. Frenchie, so good to have you here, my man, and I will catch you on the flip side. Peace out. Enjoy your dinner. Like, I kind of want to just swap in a different frequency table and see if that fixes it now. Frenchie posted a link to some stuff before. Engrams. We've got bigrams and trigrams. This doesn't seem to have a single character frequency table. I mean, should we be using bigrams and trigrams? Not just, what do you call single character frequencies? Unigrams? Are we using chi-squared wrong? One thing that's interesting is these do have a lot of punctuation characters in them. Like a lot. Do we just consider... Can you do sorted... Yeah, so you can sort a binary string by going bytes sorted. Let's, for candidate and candidates, I'm curious now, print bytes of sorted of candidate. What do these look like when you actually sort them? You know what? That's a bit noisy, I'm gonna get rid of that. So this is jumping, this is umping, a lot of characters. Here we've got punctuation and numbers, N and a bunch of Ds, and that scores well. Here we've got a vertical tab, punctuation, a bunch of numbers, and then a bunch of E's, and it also scores really well. Getting a better frequency table won't fix this, I don't think. Like, I would just expect this to score better than that. We can maybe achieve it by punishing symbols and numbers, but that maybe is what we have to do. Or are we just using chi-squared wrong? Let's have a bit of a closer read of this. Maybe we do need to bother ourselves with something called the degrees of freedom. Maybe that kind of normalizes things in a way. What if we go back to Stack Exchange? How do we get there? Function is text English. Nope. Crypto. No purple links. Character frequency analysis crypto. I think where's my util? I could have sworn I hat tipped that thread somewhere. Here it is. Excuse me, what? Deep breaths. How did we get to that thread last night? Test if text is English character frequency. Why is Stack Exchange? Yeah, good. This is it. I'm gonna. Yeah, I'll just bookmark it. Okay. So what were we told to actually do with our chi-squared? This is basically what we're doing. Who would have thought we'd be reading JavaScript? Joy. Ah, not chi-squared, 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 chi-squared. Now that Frenchie's gone, the wheels completely fall off. Chi-squared. What is this? What are we doing? We initialize count table to be 0 for each of 26 keys. And then for each character the string length, we just get what character code it is. If it's in the range. Here we're just kind of accounting for uppercase, lowercase, I think. And we're ignoring certain unprintables, perhaps. It looks like it's giving count of infinity or something for... Ah, okay. This function is like early outing if there's any unprintable characters in it at all. Which I kind of don't agree with, as I've kind of been saying all along. Maybe we do want to allow like some binary noise as a treat in our possible plain text in case it's like null terminated, or in case the ciphertext is like mostly English but has some binary data in it because it's part of a memory dump or something. I don't know. Whereas they're saying any unprintable ASCII is just not English bail, so we don't need to worry about that. So we're just building the count of each character for the candidate string. And then chi-squared is 0. We get the length of the string and we exclude ignored characters. Ah, that's interesting. That's really interesting. Okay. That would hurt these, because all of these won't count in the length of the string over which the expected count of characters is being calculated, for which the observed is being then compared to. So if you go and like drop all of these, drop them essentially, we're then seeing one N and a bunch of Ds in such a short string, and that's surely going to get a bad score. So yeah, I like the idea of excluding punctuation and numbers from the length of the string for the purposes of calculating expected counts. Okay. So we're getting the length of the text here. We're using it to assert that the text is long enough. What else are we using length of text for? We're using it to assure that the length of the text is long enough. And so I'm inclined already, I haven't read the rest of the function. Let's do it now. Length of text gets used here, good, and gets used for calculating expected counts. And that's all it gets used for. I would like not only for the length of text to only be the length or the count of the English characters for the purposes of down here, but even for this, if there's like a bunch of binary garbage and then like one, no, no, I don't want this to be based on English characters only, because otherwise this assertion is going to fire for candidates that are pure noise, and the code will never run. Total length of text is not great enough to give a meaningful score. And now we want to recalculate that length having it be just for English characters. So you know what, I'm going to assert that len text is greater than 10. Pull this down. I'm going to rename this to num English chars. And now it's only getting used down here anyway. It's not the length of text. It's the sum of C. This is bytes. It's bytes. It's the sum of B in map ord over string dot ASCII letters, string dot ASCII letters, string dot ASCII letters. Yep, it's got upper and lower in it. So we want to map ord over it to get the numeric of each, right? So if we go map ord over string dot ASCII letters, and we realize it to a list. And you get 97, 98, 99, 100, 101, So these are the lowers, and then these are the uppers. That looks good. I think I probably, do I need to realize that? I think I do. It doesn't really make a difference, so I'm going to list the map. Why am I getting yellow highlighting? B in that for B in text, for byte in text. Okay. So how does this work? This is a little bit of a hack. Let's go candidate equals hello world. Yeah. So now if we do, what do we just do? We did, let's get a list. B in, and let's do the list map ord over string.ascii letters for B in candidate. All right, so HELLO, comma, HELLO, comma, space, WORLD, bang. What we're getting here is trues in each position where this byte is an English character, else we're getting false for things like punctuation and spaces. Now if we sum that, like calculate the sum of all of these, because true is 1 and false is 0, summing this list is a way of saying how many of the characters in this, or the bytes in the candidate, are English letters. We get 10. HELLO WORLD. That's 10. Now, we don't need these square brackets. Here's another little cool Python trick. Because you'll notice over here, I'm doing sum and then a round bracket. In fact, oh, come on. We can grab this, paste it here. Yeah, text is not defined because it's candidate. We get the same value. So now, the difference between these two lines here is this has square brackets, this doesn't. These square brackets are doing what I call realizing this list in memory, which is fine. That's a nice short list. It fits into probably like your CPU's cache. Maybe, I don't know, but it's very, very small. Now, what if candidate was the entire dictionary's worth of text? Python would build this true, 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 false, 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 true, 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 false, false, false in memory and take up gigs of memory, right? The dictionary's gigabytes, maybe? I don't know, megabytes, whatever. That list gets put into memory. It's like, haha, look at me, I built a list of trues and falses, and now I need to kind of walk through it and sum the trues. By simply, so there we go, by simply getting rid of these square brackets, Python can take a shortcut. It doesn't need to actually build the list of trues and falses in memory before it starts doing the sum. So this is what's called a generator expression inside here. It's basically spinning off the series of trues and falses and passing them to sum straight away. It's like, I don't need to keep them in memory in a list because we're never going to use it again. Sum. Start counting. As I pass things to you, start counting them. So it's quicker, and it is more memory efficient to, whenever possible, just get rid of your square brackets. It's not always possible, and if you want to reuse things like this list in future operations, you kind of need to have it in memory anyway. But for when you don't need to keep it, don't build it in the first place. Generator expressions in Python are a wonderful thing. Anyway, I digress. That's how this mess works. So the number of English characters is the sum of the B's in text, where the B is in the ASCII letter range. Cool. And that num English chars is now what's being used down here to build the expected count for each C in the frequencies table. So now if we rerun our play file, we don't need to do this printing of the sorted, we just want to do the scoring of them. Debug is false. No, debug is true. Whatever, it's not that noisy, I don't think. So now the party is jumping, got negative 55. Now the party is umping, got negative 15. So still, umping's better than jumping, because J's are apparently cursed. This noise now gets dropped down to minus 92, which is worse than jumping. Good. Oh, don't do this to me. This noise still gets negative 30, which still beats jumping. I thought we would have had it. I thought we would have had it. Let's run our tests for good measure. Now we've got 2 failures now. Great. Float division by 0. Ah. Interesting. So we've got a divide by 0 error there. And we've got another divide by 0 error here. Okay. And I think we realized this before. Chi-squared breaks when the expected count is 0. Which is going to happen probably because this very readily becomes 0 for byte strings of entirely noise. How do we fix the divide by 0? I mean, does chi-squared have a defined result for when expected equals 0? Chi-squared test with 0 expected values. Chi-squared approximation is not valid when cell counts are small. Try a Fisher's exact test. Don't make me do another method, please. Okay. If the expected value is 0 and the observed is not 0, the chi-squared value would be infinity. Okay. When will the expected count to chi-squared be 0? In our case, where are we calling chi-squared? Here. Expected will be 0 when the expected frequency multiplied by the number of English characters is 0. Now, expected frequency will never be 0. There's no zeros in this table. So it'll only happen when the number of English characters is 0. In which case, if there was 0 English characters in a piece of text, it is not English, like by definition. Unless it's an empty string, which would be a very philosophical argument as to whether an empty string is English text or not. In which case, maybe it does just make sense for basically infinity to bubble up and something to then become excluded. So if we just pull in from math import infinity, is that infinity? Import math, help of math.inf. Inf -1 is still inf. I think math.inf is infinity. So for chi-squared, if expected count equals 0, return infinity. I think this should at least fix our divide by zeros. And this kind of makes sense, and it apparently, according to this Stack Exchange commenter, is kind of the definition of chi-squared is if the expected value is 0 and the observed is... if the expected is 0 and the observed is not 0, chi-squared would be infinity. What if observed and expected is 0? If they were both 1, then you get 1 minus 1 squared. So when these match, you get back 0, which we commented. We should probably account for that. If expected equals 0, if observed count equals 0, return 1, else return infinity. Yeah, so if they're both 0, return 1, else if expected is 0 and observed was not 0, return infinity. That makes enough sense to me. Let's run our tests. We only get one failure now, which is we're raising exception. That was some debug stuff we were doing. Let's just comment that out. It's really ugly debug code. We'll get rid of it later and rerun the tests. So we're still failing because we're not getting jumping, which we kind of knew was going to be the case from this test here. Because this noise gets minus 30, jumping gets minus 55, and umping gets minus 15. So our rejig did put this candidate out of the race. This one here stayed in the race. I still want to print that sorted and have another look at it. So yeah, this here scored minus 30. But like again, that's just that there's not enough characters to be really making a meaningful decision on, right? Back to this point here. Which again raises the question, do we need to punish for an overabundance of punctuation and numbers? Because that's what's going on. There's just not enough meat on the bone here to work with. Do we punish for numbers and symbols? Thing is, I'm already feeling a little bit bad about this line here, because I literally just like licked my finger and stuck it in the air and went, I don't know, punishment of 50 sounds. That sounds like enough to hurt too many unprintable characters, but There's no science behind that. There was no real reasoning. It's just like, YOLO. It feels like it's probably good enough. And then to YOLO in another finger in the air punishment to be like, how much do we want to hurt a string that has too many symbols and numbers in it? Feels like we're just digging ourselves further down that weird feeling hole. I'm inclined to just do it for each number, for each symbol, apply a punishment. I probably should be calling these penalties, not punishments, by the way. That's probably the more correct computer science word to use, penalty, not punishment. You know what? I'm going to do that. Let's globally search for punishment. That's the word I was kind of wanting to use all along. I just for some reason came up with the word punishment and stuck with it. That's good. Barney. Yeah, for sure, Barney. Like, you're not the first person to say that, and it has been super encouraging when people have said a similar thing, right? Like, it's really good to see someone else, like, it's the classic, right? Like, you look at people on Instagram and whatnot, and it's that classic thing of don't compare yourself to someone else's highlight reel, right? And as an industry, well, I found, okay, I'm not going to make generalizations here. I struggled a long time. I would go to conferences, I'd read public write-ups, I'd read advisories, and I would go, damn, everyone else is so much smarter than me. Look at what they produce. Look at how clean their work is, right? And at that point, you're comparing yourself to someone else's highlight reel. And that's not fair to you. For two reasons. One thing I found I thought of one day that gave me a lot of comfort was I'd go to a conference and I'd say, everyone else is so much smarter than me. And you know what? That's true. And my choice of words is careful. Everyone else is smarter than me. The sum of the 100 people on stage, the sum of those, they are smarter than me. Maybe if we broke it down to 1v1, I'd be smarter than some in some ways, and they'd be smarter than me in other ways. But I had this mental trap going on where I would take everyone who presented that day and I'd consider them all to be one person, and I would say, wow, that person is so much more brilliant than me. And to be true, they were. But I should never have been kind of summing up everyone on stage and doing that to myself. All right, and again, yeah, highlight reel. In a sense, I'm super proud. It's tough work sometimes showing the struggle street and the silly mistakes and whatnot. But I've been told it has been appreciated by many, and I'm very, very proud of being able to do that. Wolf, that's exactly right. It's the word I was seeking, imposter syndrome, right? I suffer from it a lot, right? And anything I can do that helps other people with theirs, I'm very proud of. Barney, when you're doing woodwork is when you're the most critical and you want it done yesterday. Right, yeah. Barney, would you call yourself a perfectionist? I would say that I haven't been clinically diagnosed, but I would not be surprised for someone who is qualified to say, Justin, you are a qualified perfectionist. I wonder if you are too, Barney. Would you say the same about yourself? Vic, you are a machine. Thank you so much, my dude. I really appreciate that. at Wolf. I don't think there's anyone who doesn't suck to some degree. I mean, I think that's a bold statement. That's a pretty sweeping generalization. I would qualify that as saying I believe many people in the industry suffer from imposter syndrome. I don't know if we can say everyone. I mean, I'm not going to stop you. That's pretty sweeping, but I would 100% agree with many people suffer from it. Alana, big hearts to you too. Thank you. Anyway, soft and squishy stuff out of the way. Let's see if we can wrap this up, because this was not meant to go on so long, but it is. Okay, so we've reworded our punishments to penalties, and we're considering penalizing, not punishing, penalizing symbols and numbers. Again, it feels kind of gross, but looking at this output here, this to the computer being more attractive than jumping. Again, yeah, I just don't think there's enough meat on the bone there for it to be making that call. And do we do it by punishing for this? Maybe. I mean, it's the hackiest, quickest way to just wrap this up and move on with our weekends. Let's do it. Barney comes up with ideas and concepts quickly. Yeah, I dig it, Barney. What I will say is, being a leader is a very different skill set to being a practitioner. It's not less or more important. Without practitioners, leaders would be... I shouldn't say... I was going to say without practitioners, leaders would be useless, but that's not true. I know a lot of leaders can practice as well, but without practitioners, practitioners without leaders would certainly be quite impaired. So, dude, you should take some credit. Take credit for the work you do. Leaders should certainly be appreciated for the organization, cohesion, and the ideas, as you say, like you come up with ideas and concepts, right? Like that's a very worthwhile thing to do. So take some credit, dude. You deserve it. You definitely deserve it. And I will say that, yeah, I'm not I'm not a leader. It's a very special skill set that, yeah, I wasn't born with, and I haven't taken the time to build that muscle. I probably would do well to do so, though. All right, let's put a penalty in here. Again, we're just gonna like go finger in the air and do 50 again. Like it just feels... No, because like full stops and commas and stuff are gonna come up quite a bit. Yeah, because full stops, commas, and even spaces, because spaces are part of punctuation. Well, I mean, we can exclude those. We can go spaces, you get a free pass. You can even say like commas and periods get a free pass. The rest of you, quotation marks. Yeah, what are we going to penalize? Let's work this out. At Wolf, I know I could never do a leadership people manager role. I'm glad I don't have to. I don't think I'd enjoy work anymore if I had to. I hear you, man. I definitely hear you. I don't think I'd be good at it, and I don't think I'd enjoy it either. And the Unix philosophy, right? Utilities should... I'm going to stop myself there. The Unix philosophy says, you know, do one thing, do it well, and work well with others. I'm not going to compare people to utilities, but I think that's still a... I should stop talking. I feel like this is going to a bad analogy place. But what I will say, dude, is like, you're kick-ass at what you do. Why would you try and be anything different, right? So I'm really glad you've got that solid boundary, right? At Wolf, is it worth stripping out punctuation? Still not going to help us, right? Like if we strip out punctuation and numbers, like the problem is this is still, because we're only calculating the expected count over the length of the printable stuff, which for this bugger of a plain text here is just not enough to work with. And chi-squared then kind of goes a bit sideways. Because if we go back to here, no. Somewhere I saw someone saying, I don't know how I ended up with 2 browser windows here. Yeah, the chi-squared approximation is not valid when cell counts are small. Like, I think any sort of frequency analysis falls over when you don't have a big enough sample size, right? Which is the problem we're facing. Do we want to make up our own rule? Where it's like, we're scoring English text by frequency. We're talking English text, potentially literature. Do we want to allow the caller of this to say, I expect 10% of the plain text to be punctuation, nothing more, nothing less. If it is more or less, then hurt it. Is that the way we should be going? Chi stuff uses the length. The punctuation is in the table. So it not being there, wouldn't that punish it more? Look, you're not wrong. You're certainly not wrong. But before we made that change, things were worse than they are now. Because remember we wanted to hurt this one because it's got a lot of N's and D's, and when you give it this much room to breathe in, the N's and the D's don't seem that overwhelming. But when you crunch it down to just that much, it's like whoa, ease up on the D's, right? And so by like recasting the observed count to be just, you know, relative to the English part of the text, it knocked this one on the head. But this one here is not getting knocked on the head. I mean, if this was like a real world thing where like you're trying to break crypto and you, as a crypt analyst, I think is the word, you know the nature of the text you're expecting to pop out, you'd probably tweak this table to be like, well, it's an encrypted JPEG, you know. Do I look like I know what a JPEG is? You would look for things that you know appear in JPEG files. Whereas if it's a email document, you would look for things that you know appear in email, which is going to be largely English text, but then like your base 64 MIME attachments go and completely ruin things. Are we overdoing this? Are we overthinking this and we should just be like hacking in something that just works for the test cases given and moving on with life? I'm starting to feel like that's where we should be headed. Alana, you got to run. You appreciate the streaming in my candor. Oh, thank you very much. Can't wait to watch the rest on YouTube and your next stream. Have a great night. I will. You too, Alana. So good to have you here. I don't expect we'll be going much longer. For those who want to stick around, please do. But I got to go soon, shortly. I've got plans this evening to make. Right, okay. Here's another crazy thought. The challenge is asking us to... One of the 60 character strings in this file has been encrypted by a single character XOR. Find it. Okay? This one here is saying, find the key to decrypt the message. You can do it by hand, but don't. Write code to do it for you. Are we overdoing it? Going back to perfectionism, are we overdoing it by expecting to emit one line only? I don't think it would be cheating to be like, here's our 3 best guesses as a computer, because this is kind of a little bit of a fuzzy, hard, weird problem. And certain edge case inputs can just make my English likeness calculation go way off the deep end. Maybe it's not cheating to be like, I don't know, here's our 3 best guesses. Analyst, you figure out which one is the plain text. You do it. What are our test cases running at? Are our test cases working apart from this last challenge? Yeah. It's just the last challenge that's not working. I don't think it's that much cheating to just go, here's our like best guess. This is a hard problem. Let's print out the top 3. What sort of broken state have I left this function in? Fine, fine, fine. Sure, there's my finger in the air thing, whatever. Score is 0, penalties. Chi squared. Consider rewarding spaces. That should really be down here. Debug code. I'll just remove this shortly. Time to go to a full AI. Yeah, let's not be so hard on ourselves, hey? We'll have to fix this test case that's failing to kind of fix the pattern of top 3. Find single chart XOR ciphertext from candidates. Let's take an argument called top n, which is an int. Given a haystack of potentially single byte XOR brute force, and return the plain texts of the n most likely plain texts of the ciphertext that most resembles English. My English ain't great, but that'll do. After being brute force, okay. Top n is an integer. By default, 1 seems reasonable. Let's just go and put 1 in as a default. And here, I mean, assert top n is greater than 1, greater than 0. Top n must be non-negative. Must be greater than 0. It doesn't make sense to say, give me the, top -1 ones. And in here we just do -1 times top n. Because if this is 3, then we want the last 3. If it's 1, we want the last 1. So now we go to our challenge 4, and we run it. Ah, that's right, we've got to parameterize that top end, don't we? So we want to print, find the... Okay. Let's do winners equals find single whatever candidates top n equals 3. Let's go top n equals 3 here. Top n equals top n. And let's go print top n most likely plain texts for winner in winners, print winner. And bearing in mind as well, like this function here could have been rejigged to also return like, not just here's the most likely outputs or original plain text inputs, but here's also the ciphertext I pulled it from, here's the key I pulled it from, exercises for the reader perhaps, or perhaps something we'll have to add in future. We'll see. Run this. Lol. So we get a bunch of numbers out. Oh, you know what? Yeah, no, this is not correct. Because I want to return like a slice, not a single item. How do you get the last n? A equals 1, 2, 3, 4, 5. So A from -1 onwards. About -2 onwards. Yep, -3 onwards. Okay. So to get the last n, you do -n colon. Good. That was pure luck that I clicked the right button there. So we go -n onwards. Put a colon there. Run this again. Oh, we've got a linter complaint here now because we're expected to return bytes. We're now returning list bytes. And of course jumping's not in there. Deep breaths. Deep breaths. We'll fix that in a moment. Because we're now returning a list of bytes, we need to go list of bytes in the type hint here. And we should just check to make sure who's calling this. The doc test is calling it, and this is calling it, and this is now expecting to get a list. The doc test is not expecting to get a list, so the doc test is going to break, but it was already broken, and it's broken down here. I'm going to put a breakpoint here. No. I'm going to put a breakpoint here, and debug it. This is some slow code. Okay. Got our candidates. Jumping had better be in here, or I'm going to be angry. Go to the console. Any jumping in C for C in candidates. Deep breaths. What's going on? Since we started using this scheme, we never retested to make sure that we're still seeing jumping in the list of needles. Let's go back to the way things were. We'll assert that the length of text is greater than 10. Again, finger in the air, we just made that number up. And the expected count is the expected frequency multiplied by the length of the text. So we're not doing the whole just the English part because, you know what, Atwolf, you made a really good point earlier about wanting to punish strings that are mostly punctuation because that increases the length. And yeah, no, you had a great point. Okay, good, good, good. Deep breaths. Challenge 4. What if we just run this now? Still no jumping. We debug it so we hit our breakpoint. Okay. Any jumping in C for C in candidates. Still false. That gets truncated. Let's revive this debugger point, which basically breaks once any of the scored candidates have jumping in them. And we can then examine them to find out why jumping's not winning that contest. Hit debug. Okay, no, I remember now. It wasn't that jumping was losing the final contest, it was that it was losing its own contest. So. Okay, I'm thinking our way of doing this was a little bit wrong all along. And perhaps I got to go shortly, so perhaps this is going to be part 1.75 of this series. I like our idea of top N, but here we were only doing top N at the point at which this round of candidates had been generated. So candidates was the most likely original plain text for each of the ciphertexts. And then we were getting the top 3 out of all of those. That was never the problem we were dealing with. Like the problem here. This problem here was that jumping was never making it into this list of candidates. Or at least for much of today it wasn't. It was being filtered out. It was losing the contest for its own population, its own companions, its own peers of potential plain texts. Maybe it was wrong for each of these. Maybe it was wrong of us to go this one here, like show me what you're made of, show me what you've got, give me your best possible original plain text. Same for this one, same for this one, same for this one, and then compete, have all of those results compete. Maybe the right thing to do was basically pool all of the possible original plain texts for this one, next to this one, next to this one, next to this one, next to this one, and pick the N best out of all of those. Maybe that was always the way to be going about it anyway, right? So rather than, getting, it's almost like this function would need to, no. Maybe having this function call breaks single XOR cipher for each one, maybe that was just a bad idea to begin with. I'm going to leave myself a note here along those lines. I think it's given me some direction for next time. I'm going to call this stream here. This was meant to be some like fun happy times maintenance that tidies up some of the stuff from last night. I feel like we broke things worse than we left them last night, but I also feel like we left things last night winning by chance, not by having done the right thing. Maybe. I don't know. Things might have gotten a little bit messier today than they were yesterday, but I think we've got some ideas that we can try next stream to clean them up. And on one hand, I'm a little bit upset with myself for still being stuck on set 1 challenge 4. But them's the breaks. I'm not a crypto guy, right? I'm also not even really much of a developer. Like, my job, for those who don't know, is to do software security work. Like, I do code review and app pen testing and a little bit of like app security architecture work from time to time. My job isn't to write code. Sometimes I write like little helper scripts or whatever, or my own little scanner tools or something like that. But I'm certainly not a developer by trade, and I didn't study computer science at uni. I didn't study software development at uni. So all that is to say, I'm going to try to be a little bit kinder to myself. We're going to leave it here for now, and next stream we will try to get our new scoring system working in such a way that this fourth challenge has a bit of a better model to it, and it returns the top end candidates, and wherever jumping appears in that list of top end, we may just have to move on, but let's see. Thank you to everyone who took time to spend it with me this afternoon. I hope you learned something. I know I learned a bunch, and I'm looking forward to doing this again. I hope you enjoy your Saturday evening, your Saturday night, wherever you are, whatever time it is for you, and I'll see you on the next one. Bye for now.